Hello, hello, hello.
Hi, sir.
Hello, Haripriya. Actually, last I could not on Friday, na everything was good, but my laptop started doing problem. Means if I plug the power button, I started the switch on it, then it starts for a while and then stops. Still, I am currently also I am joining from some other laptop, other family member laptop. You must be feeling my voice. Everything is clear, na? Just check.
Yes, sir.
So that's why I could not take your class on Friday. It was sudden when I started laptop started doing problem. And what they are saying that sir, they are saying the repair guy. They are saying it's very big shop in Delhi. They are saying sir the motherboard is gone. You have to change the motherboard. What? Because the repair guys na they are actually not efficient. They do not know. But in engineering they actually they teach. When you will go to engineering na your start, then they at that time they'll teach you everything, how to see the electronic board and all. अच्छा, what about this question, दिवा सॉल्व हुआ था?
No, sir.
नहीं हुआ. Try it now. हरिप्रिया, you? No? Try it now.
No, sir.
Try it now. Then I'll start new concept. Today I will complete it, multinomial theorem and all everything. Then we'll start the new topic. New topic I think it's circles. It's circles or वो the parabola? Circle is done for you, na? Let me check.
Yes, sir. Done.
Circles is done. Circles is done. We'll start parabola and all. Let's look at this question. What question is given? It's actually not difficult. It's easy only. But let's see you are able to do it or not. that has come now. Okay.
Then option B.
Option B. No. They are saying it is option A.
So I'm getting the general term, but I'm not able to simplify it.
Acha, let me show you then. See how you solve it. This is see what I can see here now, because the terms are going up to 10. Here if you see, the terms are going up to 10 and that's the maximum value. So the value of n that I can have is should be the value of n that should be there is it should be 10. 10 C naught, 10 C1 like that. So n should be 10. It's the expansion of 1 plus x whole power 10. Now if I take 1 plus x whole power 10 it will be 10 C naught 10 C1 into x plus 10 C2 into x square 10 C3 into x cube plus and so on 10 C10 x power 10. Now there is some more, means x square, if we integrate it once, try integrating it. If you integrate, you will get 1 plus x whole power, let me write the expression then full. Integral 1 plus x whole power 10 dx is equal to 10 C naught integral dx. I am taking this 10 C1 and 10 C2, they are all outside because they are constants. 10 C1 integral x dx 10 C2 integral x square dx plus 10 C3 integral x cube dx plus and so on 10 C10 integral x power 10 dx. Okay. Now what? Now we'll integrate 10 C naught into x plus 10 C1 into x square by 2 10 C2 into x cube by 3 10 C3 into x power 4 by 4 plus and so on 10 C10 x power 11 by 11. See, we are getting the expression. Now in the left side it will be 1 plus x whole power 11 by 11. So now only thing you have to do is put x is equal to 2, because expansion is for x is equal to 2, here everything is 2. So 1 plus 2 whole power 11 by 11 is equal to 10 C naught into 2. Acha, what Haripriya was saying? Acha, 2
I did x is equal to 1.
If you do x is equal to 1, Haripriya, how you will be getting 2 here, everything at every place?
Yes, sir, I missed it.
You are doing silly mistakes. Don't do it. 2 square by 2 plus 10 C2 2 cube by 3. Diva, you understood what approach should be followed?
Sir, I understood, but like how will we know that we have to start with the expansion of 1 plus x? We have to use 1 plus x.
See, I told you before only, in these kinds of questions you have to start with 1 plus x only, 1 plus x whole power n, because every time whenever I was solving the questions I told you repeatedly that we will be using the expansion of 1 plus x whole power n only, correct, to solve the questions, right? Remember
Yes, sir.
that? So that is fixed, that you have to use 1 plus x whole power n expansion. But how you use that particular expression, particular series to get to your desired series is up to you. There only you have to put your brain, put your mind. You have to get the idea what you will be doing with that series so that you get your desired series. Like in this case earlier I have given you questions in which you had to differentiate. Using differentiation you got to your series. But here try to differentiate. You are free to differentiate also. Just try to differentiate. If you differentiate you won't be getting the result. The second thing is you integrate. If you are by integrating you are getting the kind of result, you will get it. If by doing some other thing you are getting the result, do that. But the operations that you have to do, like we say na, for medical students, if they want to perform actual surgery and all, before that a dummy body is given to them so that they do operations and all experiments they do on this, and they do everything on that only. For you the dummy body is that particular expression 1 plus x whole power n. It's up to you what you do with that. You have only that particular formula. You do something with that and get to your desired series. That's up to you. How efficiently you are able to do that, then that efficiently you will be able to solve the question. Okay? Understood, Diva? So 3 power 11 by 11. Now I don't know what I am doing. Acha. No. But I am not getting the answer. I am getting 3 power 11 by 11.
This happened in the last class too, sir. You told me update this.
Yes, na? Why? Actually, they are giving a different one. How he solved? Is there something we are missing? We are integrating it. Should we put a constant of integration? Are we missing that constant of integration? If we put 1 plus it, wait, let me see. Because when we integrate, we had to keep a constant of integration. I'll keep it on left side, one constant of integration. Yes. Haripriya, what mistake we are doing, you know? I'll tell you what mistake we are doing. That's crucial also here. See, either you do the definite integral by putting the limits, or did you remember I told you whenever we do the integration, we customarily put one constant of integration of f of x dx. If the answer you are getting as g of x, you have to put a constant. That is the rule of integration. Remember?
Yes, sir.
That's the rule of integration. But why we are getting different answers, you know? Because we are forgetting to put this a constant. I have put the constant, but now you will ask me, sir, why you have put the constant of integration on the left side? Why not on the right side? You should ask me. Actually, I have combined them. If this is C1, this is C2. I have written C is equal to C1 minus C2. Combining them. Now the question is how I find out this value of C. If I put x is equal to 0 on both the sides, I'll get 1 power 11 by 11, which is let me write it, 1 by 11 plus c, rest all will be 0 because everything x will be multiplied is getting a 0. So c will be minus 1 by 11. So that's why now you have to put the value of c here. The value, if you put x is equal to 2 here, you have to write the constant of integration value here. So you will get 2 power 11. No, you have put x is equal to 2 now. So you will get 1 plus 2, 3. 3 power 11 minus 1 whole divided by 11. This should be your answer. Understood, Haripriya? Now we are getting the right answer exactly. And in the earlier also, when we were not, our answer was not matching, now we are confused. I think there also we did the same mistake. Did not put the constant of integration. Acha, now let's come to the next one. This is your multinomial theorem. It's a bit of higher concept, but just understand it. See why this multinomial theorem is used. अरे यार, lot of disturbance. Just wait once. Okay. Now see, what is this multinomial theorem? Multinomial theorem is used to actually solve the expansion in which more than two terms are there. See, you're able to see here now. This a1 plus a2 plus a3 plus and so on am whole power n is there. This is nothing but, see this expression. Focus on this expression. This one. Because it's unnecessary to write, because only formulas are there, nothing to derive, nothing to show you, because if I keep on expanding it, it will become so complex, and that too only very few questions are being asked on this. Only in advance sometimes they ask, that's why I am giving you. If such type of situation occurs with you, if such type of question comes with for you, then this is this. What is this? This is the multinomial theorem with m number of elements are there in this, and they are being expanded to the power of n. So the formula of this expanding is, this is n factorial divided by n1 factorial, n2 factorial, n3 factorial up to nm factorial, and each term raised to the power of n1, n2, n3 up to nm. And they can be anything, n1, n2, n3, they can be anything. They are all non-negative integers, positive integers, subjected to the condition that the sum of them is equal to n. It's like, if you compare it with this one now, a plus b whole power n, you have this one now, the term is NCR, a power n minus r, b power r, like that. So here, if you solve it, you will get n factorial by r factorial into n minus r factorial. It's like that. And a power n minus r is, they have given it n1. This they have given it as n2. So, and if you take it n1 and n2, this will become n2 factorial. This will become n1 factorial. Able to see? I am comparing this whole thing with two terms and then explaining you. Right? So this becomes like n factorial by n1 factorial into n2 factorial, and this is n1, this is n2, n minus r, and subjected to the condition that this n1 plus n2 should always be equal to n, because if you see n minus r plus r, it will become equal to n only. Correct? Just remember this formula. You understood this formula? This one? Haripriya? Diva, Kanishka.
Yes, sir.
Yes, sir.
Okay. Haripriya, what about you? Okay.
Yes, sir.
Now see, this is okay. Now, what conditions are given? The coefficients of, if they ask coefficients of a power n1, a power n2, a power m in the expansion of this is this one. It's not single, individual. If they want, I'll give you question. Don't worry. Then you will understand what kinds of how you have to apply this formula, how you have to solve questions based on this. If they have given the coefficient of a1 power n1, a2 power n2, so on and so on, am power nm, which is actually this, will be obviously this one. Coefficient will be this one. N factorial divided by n1, n2, n3 up to nm factorial. See, if you are able to understand this now, how binomial theorem works, it's actually each term is n factorial divided by n1, n2, n3 up to nm factorial multiplied with each term raised to power n1, n2, n3 such that the sum of them is n. This is how the things are going. And the greatest, these formula actually helps. The greatest coefficient is this, n factorial by q factorial whole power m minus r, q plus 1 factorial whole power r, where q is the quotient and r is the remainder when n is divided by m. Only these formulas are important actually. These 2 or 3 formulas. That's all. This also works. Coefficient of x power r in this. This is also very good question. This one. This is asked many times. When these kinds of expansion are there, the coefficient of x power r is this. Where this is actually n, but what is r? n2 plus 2n3 plus 3n4. This is equal to r. This is very important. This asked multiple times. Just look at it. Just memorize the formula. Understand the formula. I'll give you the questions based on this. How they are asked, you will understand. Let me give you a question. But remember, this is an advanced concept.
But they don't ask expansion of multinomial, right?
No, they won't ask. They won't ask. Because actually it's a partial concept. The whole thing, everything, it's not being taught to you. Only this much part is there, and that too, it is used. This multinomial theorem is actually many a times they use it in permutation and combination, difficult concepts, difficult questions. So don't worry if you feel difficult. Let me show you a question, and I'll tell you the concept also that you will be using. See, this is a kind of question that they ask. This is type, and the concept that you will be using here to solve the question is this one, third one. See if you can solve it or not. Take your time, understand. See, you will be using these two, na? Let me tell you this also. using these two, actually they have not shown it properly. Using this equation you have in n1 plus n2 up to n, and this second equation, you will get two equations actually, and you have to take all the possibilities for n1, n2, n3 equations, n1, n2, n3 values, all the possible values. Then for each possible value, get the coefficient, get this value, get this one, and sum them. So then you will be getting x power r coefficient. So because see, once you have, suppose you have got n1, n2, n3, I am giving example, it's 1, 2, 2. This is one case. So you will put because the n is equal to 5, like this something, this n1, n2, n3 value you will put like this, and then you will get the value coefficient of x power r. But that's not the answer. You can still do one more thing. n1 can be 0, n2 can be 3, n3 can be 2, or n1 can be something else, but don't repeat it. Once if you do like that, 2, sir, I am using 2, 1, 2, don't use it, because you have used it, this combination you have used it once, 1, 2, 2. And then for all these combinations, for all these cases, you are getting x power r coefficient, sum them up. Those coefficients are summed, and then you will get the answer.
Sir, I wanted to ask a question. Like, can we solve like this? Like, we have x square minus x minus 2. So if we write x square minus x as x into x minus 1, and then we take as one term, and we take minus 2 as one term, and we use binomial.
Like that also you can solve it. It's not necessary you have to solve like this only. Your way is also okay. If you are getting the coefficient of x power 5, like that you also you can solve it. I am telling na, this is actually used for the complex situations, when the things become very complex and you are not able to solve. Other way also you can use to solve.
how do you choose the values of k, in N2 and N3?
See, let me show you. We have to find the coefficient of x power 5 in the expansion of x square minus x minus 2. So, the general term that will form is coefficient. Okay, coefficient of x power 5 will be sigma 5 factorial by n1 factorial, n2 factorial, n3 factorial, because there are only 3 terms. Yes, 1, 2, 3. If there were m terms, we would have used up to m. 3 terms are only there. Now, subjected to the condition, this value is 5 now. See, this value is 5. So, n1 plus n2 plus n3 will be equal to 5. One equation. Also, from the second one we'll get n2 plus 2n3 will be equal to, because fifth term coefficient of x power 5 they are asking, it will be 5. But remember, coefficient of x power 5 was asked, that's why I have put here as 5. And here n is 5, that's why I have put this as 5. Going according to the formula. These are your situation 1 and 2. Accordingly, you have to choose the value of n1, n2 and n3. What combinations you can use is, either I can use n1, n2 and n3 now. n2 and n3 is 5. I can use n2 as 3, n3 as 1, n1 as 0. 3, 4. No.
So N1 will also be
No. N1 will also be 1, because first also have to be satisfied now. Both condition will satisfy. This is first condition. Second, what I can use is n2, n3 1 I have taken. If I take n2 1, 2 2s are 4, so this will be 2. Second condition is satisfied. n2 n3 is taken. 2 plus 3 plus 2. This should be 2. Okay. One more situation I can take. If I take n2 is equal to 5, n3 is 0, n1 is 0. Can I take any other? If I take n2 is 0, then n3 will become 5 by 2. That's not possible, because it should be integer value. n1 0, n2 n3 still be required. Only these 3 cases are there. Only these cases are possible. See, one more case was I was thinking, but I rejected it, because if I take n2 is equal to 0, then n3 will become 5 by 2. 5 by 2 is not possible at all, because it's not an integer. N value has to be integer. Now the coefficient of x power 5 that we will be getting is, this is sum, this formula. So it will be 5 factorial by 1 factorial, 3 factorial, 1 factorial plus 5 factorial by 2 factorial, 1 factorial, 2 factorial plus 5 factorial by 0 factorial, 5 factorial, 0 factorial. Everybody understood how do we solve it? Now these values you have to add it. But we are getting minus. But we have actually. Array, everything was positive. We have to put minus also. So we have to. Actually, I wrote it wrong. There is one more thing that I have to do. I forgot it. It's sigma 5 factorial by n1 factorial, n2 factorial, n3 factorial into. I have to take care of these also. 1 whole power n1 minus 1 whole power n2 minus 2 whole power n3. Why they have not written it completely? This was there, na? These terms also we have to multiply. Coefficients. This is a1 power n1, a2 power n2, a3 power n3, a4 power n4, so on and so on. Am power nm. This formula is incomplete. You have to multiply this also in this. Okay. Now this is the complete one. That's why. Otherwise, coefficients will be left. These negative signs will be left out. Printing mistake. Now see. Now this is the formula. Now the answer. Let me just do it properly. These n1, n2, n3 values I had. Now 1 power 1 minus 1 power 3 minus 2 power 1 plus 5 factorial by 2 factorial 1 factorial 2 factorial 1 power 2 minus 1 power 1 minus 2 power 2 plus 5 factorial by 0 factorial 5 factorial into 0 factorial into 1 power 0 minus 1 power 5 into minus 2 power 0. You have to sum these. Just sum them up, you will get the answer. Understood? Haripriya, Diva, how do you solve it? Kanishka, how do you solve these kinds of questions? It's a bit complex, but once you able to understand how you solve it, it will be easy for you. It has to be complex. It has to be tough because it's not an easy concept. It's not for the mains. Did you understand or not? Just tell me that.
Yes, sir.
If you are comfortable, you can do by other way also. That the way you are telling. Just solve it and then tell me what answer you are getting. See, I'll solve it. 4 into 5. It will be minus 1 minus 2. 2 only. Plus 3, 4, 5. To 5 into 4 into minus 1 plus this will be 1 minus 1 40 plus minus 120 minus 1 minus 80 minus 1 is equal to minus 81. See, I think we are getting the answer. C is the answer. So if you want to look at it, look at. I'll give you one more question to show you it's not always that we have to use this concept only, these multinomial theorem only, and I'll tell you where it actually helps. One more question you take. I'm giving. It's not coming only. Question will come. Wait. Now let me explain you the other concept by then. The other thing is multinomial theorem. The other thing is this, the other expansions of this. They are just expansion. Actually, they are used for the. Sometimes they are used, but not much. It's used rarely. Only in some question you will be using it, but if you do not remember, you can expand it also. Expand your original one to get the answer. क्यों नहीं रहा यार ये? See, try solving this question. अच्छा, you don't have time. You can do one thing. Take it as homework. Let me explain this last one. So from the next class we can start a new topic. This is binomial theorem for any index. It's nothing, just the formula that we have now, just the expansion of that. Don't fear from this. It's actually very easy. It's easy part. Just they have written it in different way. It's nothing but what? NCR. NCR is this one. This thing. So no need to fear. And what is this? This is NC0. This is NC1. This is NC2. So they have just written it in different way, just to show you these just to show you that sometimes when you see in the questions these kinds of things, you do not get fear. It's just another way of representing your original binomial theorem, right? Put the value of put x as minus x, you'll get this second one. Put the value. This is important. Why do we actually what's the need of doing this expansion? Because in our binomial theorem we say n should be greater than 0, r should be greater than 0, but sometimes it's not always that we'll be having n as positive only. Because see, when we are getting n as negative, According to binomial expansion and binomial coefficient, we cannot find out NC0 and NC1. But if we are using these kinds of expansion and put the value of n as negative n, then we can arrive at some result. Okay. So for that purpose only, this expansion type, type of formulas are being used, and this formulas these you get by just writing binomial expansion, binomial coefficients in their true forms, and then put x is equal to minus n, then put n is equal to minus n there. So these formulas will be helpful for you.
So for the negative power,
Yes.
we can't find using normal way, or it is difficult to find using normal way?
No, normal way is not possible only. Normal NC0, NC1, NC3, NC0, NC2, NC1, NC3, NC4, there they have stated na. They have actually stated in the beginning only. When NCR is there, n should be greater than 0, R should be greater than 0. The NCR formula is applicable. You can write things in this way, NCR or NPR, only when you have NS greater than 0. But it's not customary, that it's not stated anywhere that when you expand and get the value of NCR, you cannot put the value of n as negative in the expansion of NCR. That's why they write the series in these forms, and then they put n as minus n. Okay. Otherwise, if they put there NCR as minus NCR, the whole concept of NCR will become wrong.
Yes, sir, because we can't choose like negative things.
That's why, that's the problem. But so that's why they actually expand that. They make it a series, and then they put n is equal to minus n there, and then they try to find out the values. So these formulas, only these two formulas are important. Either you try to remember any one of them and put accordingly the value of x as minus x or positive x. So remember only one formula. Then accordingly, if you put the values, x as n as 1, n as minus 1, n as 2, you'll get these expansions. Okay, only so you need to remember only these. Right? This is your homework. These questions, the rest of the questions will be easy for you. It will be easy to solve. I'll give you 1 or 2 questions in the next class, and then we'll start the new topic, parabola and all. Okay. Let's end it.
Bye, sir.
Bye bye.